Okay. Hi, everyone. Thank you for joining us for this Chai Chat. For those of you who may be unfamiliar, um, this is the Americas virtual space. The Americas is a community and resource center at Stanford. We host a variety of events and programs, from weekly afternoon chai hangouts on Tuesdays to chai chats like this one, where we invite really cool guest speakers to join us in a community discussion about really important and pressing topics. Um, Today, we have a really cool event on the moon. As Ramadan approaches, the moon has a lot of significance in the month of Ramadan, but also generally for Islam and Muslims. And so I'm very excited to welcome Dr. Guessoum. Dr. Guessoum is an astrophysicist with a PhD from the University of California at San Diego. He spent 2 years as a postdoctoral researcher and later extended periods of time as a visiting scientist at NASA's Goddard Space Flight Center. He also had long ongoing collaborations with various institutions, particularly in France, resulting in many papers, mostly in gamma ray astrophysics. He is currently professor and interim head of physics at the American University of Sharjah in the UAE. In addition to his technical papers, he has published many articles on issues related to science, education, the Arab world, and Islam. He has co-authored several books, writes regularly on the mentioned subjects for the Gulf News, the Huffington Post, Nature Middle East, and other publications. He was recently featured in a full-page article in the science journal Science, and has also been named one of the top 100 influential leaders in space exploration for 2021. So without further ado, I would love to um, open the floor up for uh, Dr. Guessoum. Yeah, thank you everyone for joining us.
Uh, Thank you so much, Ayman, for the kind introduction. Assalamu alaikum, first of all. Good evening to you. I assume that everybody is over there, so it's evening. Otherwise, I would have to usually say good morning, good afternoon, good evening, wherever you are. So good evening, and thank you very much for the invitation. I'm very happy to reconnect with some people from either my university here, American University of Sharjah, Ms. Abia, or Ayman, who's actually, whose family is here in Dubai. So I'm very happy to be reconnecting. And as Ayman mentioned, I have long-standing connections with California in general, particularly Southern California. So let me start. I have a lot of slides. I'll try to keep it to less than an hour, less than half an hour, sorry. I scared everyone. Less than half an hour. But as you can imagine, there's quite a bit to say on the topic because I actually titled it, let me see, titled it "The Moon and the Crescent in Islam." So share this and just launching here. So the moon and the crescent in Islam, because there's essentially two connected topics in this, and I wanted to give you a little bit of flavor of each. So let me begin. The moon in the Quran, as you know, we always start with the Quran in Islam. People have stressed and have known that Islam is really a religion based on a book. The book is many times more important than even the Prophet himself, and he is the seal of the prophets. So we always start with the Quran, we always relate back to the Quran. For those of you who are not Muslims or may not be thoroughly familiar with the Islamic religion and culture. In any case, the moon is mentioned 26 times in the Quran with 3 overlapping themes as far as I can read. One is the moon is a subservient creature of Allah. It is a creature that sort of bows to God, responds to God, is in the service of God. Number 2, the moon is service and benefit to mankind, has been created to help us, to provide some service to us. We will see how later. And the moon, there's a number of verses that stress the fact that the moon follows an order, a law, some computation. The word even computation is mentioned a couple of times in the Quran, that there is a numbering or a formula or a law or order that the moon follows. So the 26 verses sometimes stress one of these themes. Sometimes you find even two of the themes stressed in the same verse. To give you an idea, and I'll just go over some of these verses very briefly, and I've written here the original Arabic verse for those of you who know Arabic. If not, then we have the English translation. So one of them, for example, under the theme of the moon being a subservient creature of Allah, God, among his signs are the night and the day and the sun and the moon. Do not prostrate to the sun nor to the moon, but prostrate to Allah who created them, if it is him that you worship. Number two, do you not see that to Allah submit in obedience all that are in the heavens and on earth, the sun, the moon, the stars, the mountains, the trees, the animals, and many people. On the second theme, that the moon is a service and benefit to mankind now, Allah is he who raised the heavens without any pillars that you can see, is firmly established on the throne. He has subjected the sun and the moon. Each one runs for a term appointed. He regulates all affairs, detailing the signs that he may be certain in meeting your Lord. And then another example, there are a number of verses under this theme. Second example, and he has made subservient to you the sun and the moon, both pursuing their courses, and he has made subservient to you the night and the day. And then the third theme is that the moon follows a prescribed order or computation. It is he who made the sun radiant and the moon a light, and ordained for it, for the moon, mentions or stages, today we say phases, that you may know the computation of years and the count of time. Allah did not create that, but with truth. He makes the signs manifest for people who know. And the moon we have ordained for its stages till it becomes again as an old dry palm branch, meaning a very thin crescent. They ask you about moon phases, say they are times set for the benefit of man and for the pilgrimage. Another important idea that I wanted to just touch upon briefly is that astronomy in general, not just the moon, but the moon and the sun and the rotation of the earth itself, plays an important role. The whole field of astronomy plays an important role in Islam and the Islamic tradition, the Islamic actions or activities of Muslims. So for example, prayer times are related to the position of the sun in the sky, and that requires some astronomy. In fact, you probably know that in some regions of Earth, particularly those that are close to the poles or the so-called Arctic regions, the problem of determining the prayer times is a problem that has not been completely solved to this day. But this is not our topic for today. That's maybe another topic, prayer times, how to compute them and what to do in places where the sun doesn't set sometimes, or the sun stays under the horizon for for weeks and sometimes months. The direction of Mecca is also, surprisingly, people might think, well, this is geography, this is not astronomy. Well, actually, if you need to know, and you have to know for prayer, where is the direction of Mecca, whether it is east or over the poles where you are over there in Northern California, Muslims pray to the direction of north because it is closer to reach Mecca through the poles. As you know, when you take a long flight, for example, Ayman, when he goes to Dubai to visit his parents or goes back to California, the flight goes over the poles. In any case, to decide in which direction to orient yourself if you want to face Mecca, you need some knowledge of the direction. So for example, if you are in some city or in some location one day or one evening, and you need to know, suppose you know that in your location or in that location, for example, here, I know from the Emirates, I have to pray almost exactly west. So I need to know where is west. And in order to know where is west, I have to know where does the sun rise or set. And if it is in the evening, then I look at the moon. And if the moon is not there, then I have to look at the planets. And from the planets, I figure out the so-called ecliptic. And the ecliptic goes roughly from east to west. So that determines the directions for me, where is east, west, south, and north. And from that, I can determine where is the direction of Mecca. So that requires some astronomy. But most importantly for our topic today, the crescent and the moon play an important role because the observation of the first crescent of the month, in this case, the month of Ramadan, the 9th lunar month of the year, starts the month of fasting. And then the appearance of the next thin crescent, typically 29 or 30 days later, signifies the end of Ramadan. But this is, of course, a regular thing. This is not just for Ramadan, this is for every lunar month. But lunar months, as you will see in some detail in a minute, can be defined differently depending on certain criteria. Now, people might think, if you look back at the image I just showed here, for example, you may think, well, that's a trivial matter. You just look at the crescent, and one night there is no crescent, the next night there is a crescent, and case closed. The following day, you have to fast. But actually, the situation is far more complicated, far more difficult. So I'm showing you here some images. I'm sure you're struggling to look and see where is. In some cases, the crescent is quite visible, and in some cases, you think, where is it? And that's the problem. If you rely on visibility of the crescent, depending on the month, depending on the season, depending on meteorological conditions, depending on your geographical location, how far north or south you are, and what kind of longitude where you are. You are in California, I am here in the Emirates, people are in Europe, and so on. It may be either easy to see the crescent or extremely difficult, and in some cases just impossible. So in some places in the same evening, in some places it may be easy, in some places it may be utterly impossible, and in some cases it'll be difficult, and it may require viewing through a telescope, for example, in that upper right-hand image. That is an image taken with the aid of a telescope. So sometimes you can't see it with your eyes, but you can see it with a telescope. You can take a picture with a digital camera, and in that case, then the Muslim scholars have to decide, do we accept visibility? And there is some debate, although the majority now accept that if you see it with a telescope, that's perfectly fine. It just says you have seen it. It's as if, it's somewhat different, of course, but people consider it is as if I have used my glasses to see better. So looking or observing the crescent can fall under three basic situations. One is the moon. Here, the orange disk that you see represents the sun, and the blue or dark one here represents the moon, which at the beginning of the month is going to be mostly dark, except for a very thin edge. That's the crescent. And that one is at the bottom, is always at the bottom. And you can see that the sky here, because the sun is still up in the sky is going to be bright and blue, and a thin crescent like this here is not going to be seen. In fact, if you want to see the crescent, you have to wait until the sun has set below the horizon by at least half an hour, so that the sky has darkened enough, and then maybe you can see the crescent. So this first situation is impossible. The moon is going to be setting before the sun. There's nothing to see after sunset. And there is a situation where the moon sets shortly after the sun. You can see here the sun is just about to set, is just about at the horizon, and the moon is just over it by a few degrees, and so is going to set here, but set only a short time after. The sky will not be dark enough to see the crescent. It'll be too thin and too difficult to see, and sometimes too difficult to see even with a telescope. So in this situation, there's some debates as to, yeah, but the moon is there. It is setting after the sun. The lunar month, the moon has started its cycle, its new lunar month. And so there's some debate among Muslim scholars as to, do we start the month with this, or do we have to actually see it with people's eyes, or see it with digital cameras? What you see here in gray is what this crescent would look like if you try to capture it with a stack of images taken with a digital camera, and then you can construct the crescent like this. This, right now, most Muslim scholars consider this not acceptable, because they say this is not viewing, real-time viewing, this is imaging. You have taken a bunch of images and stacked them, and there is no real processing other than the stacking of images, but this is not quite acceptable. And there is the the moon setting long enough after conjunction. As I've said, I will give you the times and the required time intervals a little bit later. But if the moon sets after the sun, let's say by 45 minutes, an hour, or something like that, then it becomes somewhat easy to see, at least with telescopes, if not with naked eye. So these are sort of the three general ideas. Astronomical studies are divided, have been divided for centuries and centuries, this problem of predicting and knowing ahead of time. So the astronomers are not just interested in, if I go out this evening, can I see the crescent? They are, that's a matter for astronomy for sure, but they are more interested in, can I determine ahead of time which evening people will be able to see the crescent or not? And this problem of trying to predict and determine whether the next crescent will be visible and on which evening, so that we can tell ahead of time when, for example, Ramadan will begin or end, this problem goes back centuries and in some cases to millennia, because the Babylonians also had a lunar calendar and wanted to know when the month would begin. So essentially those studies fall under two big themes. One is completely geometric. So if you can determine where the crescent is, and for a long time we have had good enough astronomy to tell us where the moon is at every moment of every day of the month. So we know where the moon is compared to the sun. So we can calculate ahead of time these angles that you can see on the screen here. You don't need to remember this. This is just to show you that there are some geometric considerations. And then astronomers, again, going back centuries and centuries, formulated some simple criteria or simple rules saying, if this big angle, the arc of light, this direct angle between the moon and the sun is more than, say, 12 degrees, then the crescent will be visible. If it is less than about 10 degrees, it will not be visible, things like that. The other topic which started in the 20th century is to say, no, you cannot go with geometry, because in the end, the geometric angles don't say anything about the local meteorological conditions, which are absolutely critical. You have to consider sort of an astrophysical approach, where you're looking at not only the positions of the objects, but the physical conditions behind that. So those are the two sort of approaches. Crescent visibility criteria, as I said, go back centuries. So for example, Muslim astronomers, going back to the 8th century CE or AD, you can see here a brief list of some of the main or prominent Muslim astronomers who worked on this topic. Ibn Tariq, Al-Khwarizmi, the father of algebra, Al-Battani, one of the biggest astronomers of that whole era, Ibn Yunus, Al-Tabari, Al-Tusi, who was in charge of the biggest astronomical observatory built until probably the 20th century. So they had some criteria. I mentioned one of them in passing just a minute ago. This is the so-called Babylonian criteria, that if the angle between the sun and the moon is more than 12 degrees, which translates to at least 48 minutes of lag time, we call this, the time it takes, the time interval or difference between the setting of the sun and then the setting of the moon. If the difference between them is more than 48 minutes, or the angle between them is more than 12 degrees, then the crescent will be seen. And then some others started to fine-tune this criterion, because they realized that sometimes it is less than 12 degrees or 48 minutes, and yet you are able to see the crescent, because again, it depends on meteorological conditions. So for example, Ibn Tariq that you see up there said, no, we go with 10 or 10 and a half degrees. Ibn Yunus, for example, said, no, you can actually go as low as 9 degrees, which means about 36 minutes. But all of these are geometric criteria, and thus of limited reliability, because it doesn't say what the meteorological conditions will be here. Here we have terrible sky conditions almost all year round, because we have strong heat, and the heat produces turbulence in the air. We have a lot of dust around us, although there's a lot of greenery, but there's a lot of dust. We are in the middle of the desert, essentially. So the dust fills the air and prevents visibility. We are near the coast. and the coast produces humidity, water vapor, and that water vapor hinders observation. So all of these are factors that are not included in these simple geometric criteria. Now, there's a number of other things to know about crescent visibility. And for example, records. What are the smallest time intervals, for example, smallest age, smallest angle under which people have ever seen the new crescent? Now, it doesn't mean that if now, for example, next week, since Ramadan, the night before Ramadan is going to be next Monday, April 12th, it doesn't mean that if, for example, on that night, the moon sets after the sun by more than a certain time. So these are records, but they are not predictors. It doesn't mean that if you exceed these times, you will be able to see, because again, as I said, it depends strongly on meteorological conditions. But what we know for until now, for centuries of observation, is that the moon, the crescent, has never been seen when it was less than about 15 hours young. The age, what we call young or age, is how much time has passed since the moon has started its new cycle around the Earth, since new moon. If you know what new moon is, or conjunction, meaning when the moon is exactly in between the Earth and the sun, and now is starting its new orbit or new cycle around the Earth, that time is t equals 0. We start counting from there. Now you need at minimum 15 hours and usually more like 24 hours for the crescent to become thick enough to be visible with naked eye. So here is for naked eyes, minimum lag time. Lag time is how much time it takes for the moon to set after the sun. And we have never seen the crescent in after less than 29 minutes. Now it shows you when these records were established in recent times. What about optical aid observations with binoculars, with small telescopes? These records above there are reduced a little bit. People think, oh, with the telescope, you'll be able to see anything. That's not true. There are some limited intrinsic limits to even the optical instruments. And so, for example, even with telescopes or with binoculars, we have never seen the moon or the crescent when it was less than about 12.5 hours of age, meaning after new moon or conjunction. And we have never seen the crescent when it's set, even with telescopes, we have never seen it when it's set less than 20 minutes after the sun. Now, we have had, the situation became even more complicated because, as I said, a new technique was introduced about 10, 15 years ago. And that technique is taking stacks of images, many images with digital cameras, CCD cameras, and then stacking them. And in doing so, you can really see the crescent, in fact, in the middle of the day, even with a blue sky, as you can see in the image. I assume you can see the crescent here, but this is the record of the thinnest and crescent at conjunction. I can explain this, but this is just to show you that things have become even more complicated. Here's another one here, a lot more visible. You can see an age of only 3.5 hours. Elongation meaning what is the angle of separation between the sun and the moon of only 5 degrees. And this is extraordinary. But that creates even more complications for the Muslim scholars because they have to decide, is this acceptable or not? If you see the crescent even before sunset, is that valid or not valid? There have been modern studies with the participation of many non-Muslim Western astronomers, because some people early in the 20th century looked at the problem and said, oh, this is a fascinating problem. It has all kinds of factors and complications. Let's see if we can participate or say something scientifically useful on this. So there were some British astronomers, Fotheringham and Maunder, who plotted, this is a plot from, from the data that goes back to 1910 and 1911. And they try to determine, you can see the curves here, to determine the curve above which you see dark dots, which means crescent will be visible. And under it, you can see some open circles or open triangles, and that means the crescent will not be visible. There's a famous French astronomer, in fact, director of the Observatory of Paris, Danjon in 1932 came up with this limit saying you will not be able to see the crescent ever if the angle between the moon and the sun is less than 7 degrees. Now, even this limit that Danjon established in 1932 has now been fine-tuned, and people now talk about 5.5 degrees or 6 degrees. There's a whole reasoning behind this. Bruin in 1977 was an American astronomer who worked at the American University of Beirut in Lebanon, and with interacting with Muslims realized that there is this long-standing problem, and he was the one who contributed an astrophysical approach by calculating the brightness of the moon at any moment, compare it to the brightness of the surrounding sky, calculate a contrast between them, and figure out what is the minimum threshold of contrast under which you would be able to see the crescent. Really, really innovative and wonderful scientific piece of work by Bruin, 1977. Ilyas in Malaysia participated also in 1984 by introducing the so-called International Lunar Date Line, which I will explain in a minute. Now, recently people have set up some criteria. Maybe I can jump over this. This is similar to the previous ones that I had shown. Now, let me show you, this is for the month of Sha'ban. This is the month preceding, for this year, this is the month we are currently in, the month of Sha'ban, which precedes Ramadan. So Ramadan, as I said, is in about 2 weeks. So 3 weeks ago, the lunar month of Sha'ban would have had this kind of map. So what is this map? This map, you can see the limit here between the red zone and the white zone. This line here that separates these two zones is the so-called lunar date line. This is what Ilyas introduced by saying, in the red zone, the moon has not started its new month. And in the white zone, the moon has started. So meaning we are in the white zone here, we are in the new lunar month. Whereas if you live in the red zone, on that evening, the moon has not even started its new lunar month. Now, what about the blue and the purple? The white zone here says the moon now has started its month, but is now too young and too thin to be visible with anything, with even the biggest of the telescopes or binoculars or anything. If you are in the blue zone, such as you guys are in California, this is three weeks ago, I'll show you the situation for Ramadan in a minute, then it means you will be able to see this crescent, but only with optical instruments. You will not be able to see it with naked eyes. Now, let's look at Ramadan. So this is next Monday. Next Monday, you can see the lunar date line, which separates the red from the white on the at the extreme right. So most of the Arab Muslim world here is in the white, meaning the moon is over the horizon, but extremely difficult to see, or actually not possible to see even with telescopes. Now, most of Africa is in the blue, meaning people here should be able to see the crescent with instruments. Now, you guys over there are in purple, which means you should be able to see the crescent with your naked eyes if the meteorological conditions are very good. And then the green zone here means people, if there are any islands in the Pacific over here, will be able to see the crescent very easily. So this is Monday, 12th of April. Now, a month later, for the end of Ramadan, for the celebration of Eid, end of Ramadan, the start of the month of Shawwal for us, you can see that, for example, on the 12th of May, most of the Arab Muslim world will be either in the blue or in the purple or pink, and that means the crescent will be visible either with telescopes or with naked eye under very good meteorological conditions. And you guys in California are in the green, which means you will be able to see it very easily with naked eyes. So this is all the, I'll skip over this chaos business. I just want to maybe, let me see what time it is. I don't want to take way too long. I'm already a bit late. So I want to say some things about the Islamic calendar. So some of us, many of us Muslim astronomers have called for the establishment of an Islamic calendar. We said we can't keep waiting for the evening. I skipped over a slide called Chaos Ensues, because if you wait and that evening, as many of you have experienced, then you have all kinds of situations, people claiming to have seen it here, not seen it there, the astronomers saying it could not have been seen there, what are you talking about? and then you get chaos. So many of us for years and decades now have been calling for establishing an Islamic calendar based on crescent visibility criteria. We can predict and calculate. I showed you the maps, and then we can say in this region, the crescent will be seen, will not be seen, and then we know ahead of time. So we establish a calendar. There are essentially 2 or 3 types of calendars. I'm going to just show you sort of big graphs here to conclude quickly and open the floor for discussion. One is either bizonal or trizonal calendar, meaning we divide the globe, the Earth, into 2 or 3 zones. If you divide it into 2 zones, there's a big yellow line here in the middle of the Atlantic, and then you have a western region and you have an eastern region. And then you can establish a calendar for everybody in this region and everybody in this region. And typically, all of these eastern and western regions would overlap, would have common calendar for 3/4 of the year. And for 1/4 of the year, as you saw from the previous maps, the crescent would be visible in the western region. The crescent is always easier to see the more you go west. So sometimes the crescent will be seen in the western region and the month would start there, but would not start in the eastern region. This happens in about 25% of the cases. And so for the eastern region, the month is postponed by 1 day. Now, this is the calendar I proposed about 10 or 15 years ago, and that bases its criterion on conjunction at Mecca before Fajr. Fajr, for those of you who are Muslim, know is the dawn prayer. It's not actually dawn, it's pre-dawn. It is the first light of the first rays of light that we see about an hour and a half before sunset, before sunrise, sorry. So we call that Fajr. Those of you who are Muslim know what Fajr is. So my criterion was very simple. I said, if conjunction between the earth, the moon, and the sun happens before Fajr happens in Mecca, then the month begins. And if that happens, then the entire world will begin together. If that does not happen, then you have 2 situations. Either it happens before noon, and then the eastern region begins, the western region begins, and the eastern region postpones it by a day, or if it doesn't, then we postpone for the entire world. And then there is the totally unified calendar, which has been proposed by some other Muslim astronomers who say, no, we should have just one calendar for everybody. If the crescent is visible anywhere, even if it is visible, let's say in Hawaii, but it's not visible here at all in the eastern region, then everybody should accept that the month has started and start the month. And some of us have objected to this, and we say, but if the crescent is visible in Hawaii, then the moment it is observed, then the day will have started in the eastern regions, let's say in Malaysia, or even in the Indian subcontinent, or even in the Arabian Peninsula. You can't base the start of a month in some region when the crescent is visible in the extreme west. Anyway, so there's some debates. I just wanted to give you sort of a flavor of some of the topics that are associated with crescent visibility, Islamic calendar, the moon in general. So thank you for your attention. I'm happy to take questions.
Thank you, Dr. Guessoum, for such an informative lecture. There was a lot in there. So we want to